Hi everyone, what you need to know number 3 up right now. So what is the solution to this equation? Just solving for x and use your calculator. Use your calculator, I suggest, because the first thing that you do have to do is distributive property. And distributive property, you do 3/5 times 5 and then 3/5 times -10. And you press this button right here to put the fraction into that calculator, and it is 3/5. And then you times 5, and it just makes it a lot easier to get that answer. So it's 3x. So now it is, you press the same thing, it is 3/5 times -10. And it's times a -10. Enter -6. And you bring everything else down, and then you just solve like you normally know how to solve a two-step equation. Again, you need to know this for next year. Use the inverse of a -6. You add 6 on both sides. Once that happens, this cancels, it equals 0, that's y, and it's 3x equals 26. And the opposite operation of something multiplied is division. You divide by 3 on both sides, and you get 26 divided by 3. Again, you could put that in 26 divided by 3. And you get x equals 8.6, and you could round it off. Let's round it off to 8.67. Or you could put 8.6 with a line on top. All right, since that goes on forever like that. All right, number 2, let me get this out of the way. Number 2, which relation is a function? Remember what we went over. A function is when every x, every input has its own output. Every x has its own y. So if the x repeats, it's definitely not a function, right? Because every x, it usually doesn't have its own y at that point, right? So if an x repeats, it usually goes to a different y, and that would make it not a function. So they're asking for which relation is a function. So we have 3/4 here. We're looking at the x's, then 0, and then 3/4. You notice that 3/4 goes to 0, and also 3/4 goes to 2. That means the same x has 2 different y values. That is not a function. Let's go to number 2. -2, -1/2, -2 again. -2 goes to 2, -2 goes to 4. Again, the same x going to different y's. That is not a function. Let's go over here, -1, 0, 5, and 0, 4. Again, that 0 goes to 5 and 0 goes to 4, so that means it is not a function. And let's just check number 4, because that's the answer. 4, 2, 6, 2, 4, and 6 as the x values. All x's have their own y. Every input has its own output. And that is the answer, choice number 4 for number 2. So number 3 says write each in standard form, and there's 2 questions. You have to have a calculator for this. You don't have to have a calculator, it's just much easier, and we're just going to go through with the calculator. Hopefully you do have one at home that you can use. And I'm just going to move this up, and we'll start off with number 3. So the next questions ask, all right, these are scientific notation, but they want the answer in standard form. So I'm going to put this directly into the calculator. 5.6 times 10 to the third. And by the way, this caret button over here allows you to put that exponent in of 3. Just remember to press the right hand button right here to get away from the exponent as far as the exponent goes. I'll do it again over here, 2.9 times 10 to the 7th power. And you notice that this is up here, and it's saying here, press to the right. If you do go ahead and put this parenthesis, it'll be a small parenthesis, and that won't work. So I'm going to press to the right and put the large parenthesis down. So you notice that we have 1.624 times 10 to the 11th, and that's all the calculator is giving you. So I'm going to write that down, and the reason why it's giving you that is because the number that that translates to that in standard form is not going to fit on the calculator screen. So if it doesn't fit on that calculator screen, it's just going to give you the number in that scientific notation. So I'm going to put 1.64624 down, and it's times the 11th power. So I am going to move this decimal over 11 places to the right, making it larger. And remember, every time that you have I'm going to add some zeros here, just so I have as I'm moving this decimal, I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and one more 11, and I'm going to add a 0. So that number, whatever that number is, and I'm not even going to try to say it, cannot fit on the calculator screen, and that's the reason why it gave it to you back in the scientific notation. So 1, 2, 3, 4, 5, 6 zeros, 7, 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8 zeros. And then put your commas in so the number really makes sense. And there you go. All right. And again, standard form for this one right here, press this button, and we are going to put 3.2 times 10 to the 3rd power as the numerator. And then press down for the denominator. 6.4 times 10 to the 9th. Enter. And it gave you the number in standard form, which is really helpful. 0.0, let's see how many zeros. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and then a 5. Pretty easy when you have that calculator. Really nice and easy. All right, so that was number 3. Number 4, which one is not equivalent to this? And you could do this in the calculator, or you could just use the way that we taught you using the laws of exponents. But if you don't know the laws of exponents, that means you have to use the calculator. Let me use the laws of exponents first. When you divide the same base by the same base, what do you do with the exponents? Yep, you subtract them. So 3 minus 8 becomes what? 7 to the negative 5th. So 7 to the negative 5th, we're looking for one that is not equivalent, not equal to that. So that means this is out. Do you remember when we said, what happens to when you have a negative exponent? What do? Well, you could put a 1 underneath and flip it. Remember, take the reciprocal. You have 1 over 7, and then since you're taking the reciprocal, the exponent now becomes positive. So 1 over 7 to the 5th is equal to that as well. That's out. Now, I'm thinking 7 to the 5th is this number here. All right. And I know that 7 to the 11th is not this. So this is the one that's not equivalent. And this is out. All right. Again, you could use your calculator to, oops, this is the wrong one. Wrong calculator. You could use your calculator to put this in, and the way you would do that is 7 to the 3rd and over 7 to the 8th power. And then you would press enter. And see this number here? If you put 1 over 7 to the 5th, you would get that number. If you put 7 to the negative 5th and press enter, you would get that number. If you put 1 over this and then convert it into a decimal, you would get this number. This one, you would not get this number. So that's how you know that that expression is not equivalent, not equal to. Number 5, which is the following, is a linear equation. So linear equations, you remember what the formula for a linear equation is: y equals mx plus b. So anything in that format, you will say is linear, is a straight line. So we're going to look for that format. Y equals x squared. As soon as it has an exponent next to the variable, it is not linear. Here we go, 3x to the 3rd, nope. Y equals 5x plus 10, that is y equals mx plus b. So that is your linear equation. And again, 2x squared minus 15, no good. C is your answer, and that's it. Nice, easy question. We're talking about a square that is a vertex A is located at 8, 3. A dilation. You remember what a dilation is? Remember we talked about the eye drops in your eyes. When you dilate your pupils, they get larger or smaller. A dilation centered at the origin takes place as a scale factor of 3. So we have a scale factor of 3. Does everybody remember what to do to dilate just 1 point to a scale factor of 3? And they want the coordinates of A prime after the dilation takes place. So 8, 3. 8, 3 is A. What is A prime after it's been dilated to a factor of 3, scale factor of 3? 8 times 3, multiply, and that x value now becomes 24. There is only one x value of 24. So I am going to say that the answer is B. So I just want to prove that 3 times 3 for the y is 9. So 24, 9 is your answer, dilated to a factor of 3. And that's it. Can you tell me what this dilation is to a factor of? If it starts out as 8, 3 and goes to 16, 6, what would this dilation be? All right, yes, it would be a dilation of scale factor of 2. All right, so what's the measure of angle C? So the measure of angle C. So take a look. This is what they're looking for right here. I like to mark it on there. This is a 90-degree angle. B and C equals 90 degrees. But take a look at this is 145. If I fill this in, this little gap right here, that little blue part, this is a straight line. Do you see it? So that means what minus 145? If you get B, then you could get C, because B and C equals 90. So what is this straight line equal to? If you're saying 180, you're correct. So you have to do 180 minus 145. So go ahead and do that in your calculator or on your fingers or in your head. 145, 155, 165, 175 is 30, and then 5 more is 35. Notice that they have 35 as A. That's the measure of B, but that is not the measure of C, so that's not the answer. So to get C, B and C added together would be 90. So 90 minus 35 would be the last part of what C is, that missing part. So how much is it? It is 55 degrees. So B would be your answer there, and this is 55. Notice that 55 plus 35, if you want to check it, equals 90 degrees. Notice that 35 plus 145 equals 180. So for the next problem, Bob wants to solve a system of equations graphically. Why? Who knows? Maybe he's bored. Graph each equation and find the coordinates of the system of equations. Right? You're going to have to do this in high school in your next math class. So please make sure that you do know that the slope, the y equals mx plus b, is the equation of every line. Y equals mx plus b. And that doesn't look like an x, but you get the idea. So this is the m, which is right here, and this is the b. So the m, we always said in our class to put it in rise over run format. The b is the other number. So the rise over run format, rise 2, run 1. Very easy. Let's go ahead and graph that now. We start here. This is your starting point, your y-intercept. So I'm going to put a blue dot at 1. That is the y-intercept. And I'm going to rise 2, run 1, and put another point. Rise 2, run 1, put another point. Rise 2, run 1, go up, and keep on going until you run out of space. So you need more points down here, and this trend must continue. So you go down 2, left 1, down 2, left 1, down 2, left 1, down 2, left. And you keep on going like that until you run out of space on the graph. Now to connect those points, you connect it with a straight line, connecting all of those points. And remember, put an arrow on either side. And when you put that arrow on either side, you're ready to go ahead and just put y equals 2x plus 1 on the line or somewhere near it, so you could label that line. And don't forget that you're graphing, when you're graphing two or more lines, that you do have to label those lines. So the fact of the matter is right here is that this equation is not in y equals mx plus b format. So that means you have to solve for y. How do you solve for y? You have to get y alone. So these, the 2 and the y, are attached by multiplication. So what is the opposite inverse operation of multiplication? It is division. So we divide by 2. Whatever's next to the y, you're dividing by, and you're dividing by 2 on both sides. This cancels, and you have y equals, and then you have to do some division, which is pretty easy because 4 divided by 2 right here is 2. You bring the x down, and 10 divided by 2 is 5. This is your y equals mx plus b. So now you're ready to figure out the slope and the y-intercept. The slope is 2 over 1. Remember, always put it in rise over run. The 2 is a rise, and the run is a 1. Going to the right. And then the y-intercept is 5. I'm going to put this in a, use different color for the point, different color for the points, and we are going to start, instead of starting at 1, we are going to start at 5, because that's what the y-intercept tells me to start. That's where this line crosses the y-axis. So now I am going to go up 2 and run 1, just like the other line, up 2 and run 1, and then up 2 and run 1. Down 2 and left 1, down 2 and left. And you get the idea. You could do this on your graph as well. Just like that. And when you're ready and you've run out of space, you go ahead and connect those points. Just like I did the other line, I am going to connect, get this together, the points, just like that. Making sure that there are arrows on both sides. So I am going to put y equals 2x plus 5 on that line. Notice that the lines that I have here, I'm going to move that one over, are what? Two lines that don't meet, never meet, are called parallel lines. So what is the system, the solution to that system? There is no solution, so just put no solution. No solution because, again, none of them, they don't meet, they don't intersect at all. There is no solution. And can you remember in class when we were talking about no solution equations, what do they have the same of? And what do they have that's different? They have the same slope and they have a different y-intercept. Remember, no solution would have to have the same slope, and they do have the same slope of 2, but a different y-intercept, and they do have different y-intercepts. That is no solution. That is your answer, and that is that. So number 9 is a two-part sequence, and this is a transformation question when they're asking you to rotate the triangle 180 degrees about the origin. So here we go. When you rotate something 180 degrees, there is a rule that is really easy to remember, but maybe you're not going to remember it. Okay, but when you do rotate something 180 degrees, you're going to rotate your paper around until it's upside down. And do you see what happens when you rotate it upside down? That's the triangle. This is what it's going to look like. So if you take a look at this triangle, this triangle is going, this is quadrant number 1, this is 2, this is 3, this is 4, right? It's going to be in the lower right hand corner and it's going to point down, right? So when I go back, I should know that this triangle rotated 180 degrees is going to go into this quadrant right here and it's going to point down, right? So let me go back and I'm going to put point A on right now. This is without using the rule. So point A, from 0, 0, we're going to count 5 to the right and 7 down. 5 to the right and 7 down. So I'm going to go back and I am going to do 5 to the right, 5 to the right, and 7 down. And there's my A prime. Let me put A prime. And then it's time for my next. I'm going to rotate it again, right? Like this. It's 180 degrees. Now I'm going to go to B, 3 to the right and 2 down. And then I'm going to go back and go 3 to the right and 2 down. 3 to the right, and 2 down. And that's my B prime. And one more, which is C, thank goodness, is 180 degrees. And C is 7 to the right and 2 down. Let me turn that right back around. 7 to the right and 2 down. Okay. 7 to the right and 2 down. And that is my C prime. So keeping with what I was talking about when I first rotated it, the rotation of 180 degrees is pretty simple, right? Do you see what my result was? It was exactly what it was when I rotated and looked at it. It was pointing down. It was in this quadrant. Also, just wanted to make sure that you understand that A, about the rules, A was -5 and 7. A prime became, after the rotation, A prime became 5, -7. So take a look at the rule X, if you knew it, XY became, just changed from -5 to positive. So that means if it was positive here, it becomes negative. And the Y became negative, changed its sign also. So that's the rule for 180 degree rotation. XY becomes -X, -Y. If it's negative, then it becomes positive. All right, so that's it. So translate, B is translate 5 units to the left and 2 units down. So I am going to make a little label for myself, 5 to the left, 2 down. That's like a little key, little shortcut. Now you don't have to read it, right? So you have 5 to the left. I'm going to take A and go 5 to the left. 1, 2, 3, 4, 5, and 2 down. 1, 2. And I'm going to put this point right here, and I'm going to put A double prime. It's the second thing that I'm doing. I have A double prime. So B is 5 to the left, 1, 2, 3, 4, 5, and 2 down, 1, 2. And you put a B double prime. And C is 1, 2, 3, 4, 5, and 2 down, 1, 2. And that's C double prime. Connect those points, and you have your second transformation. You have your translation, 5 units to the left, 2 units down. You rotated it 180 degrees about the origin. You are finished, and that is the answer. Right? You remember some of the stuff that we went over today on this, what you need to know, number 3. And thank you for watching. See you next time.